Hello, everyone, and welcome to this live stream on the MATLAB YouTube channel today. My name's Connell D'Souza. I work on the student competition team here at the MathWorks, and I've got my colleague Sam along with me. Sam, do you want to go ahead and introduce yourself before we get started?
Sure. Yeah, so my name's Sam Reinsel. I'm also on the student competition team here at MathWorks. I primarily do automotive competitions, but we hang out and support any competitions that everybody else needs help with.
Yeah, I see you've got your EcoCar branded T-shirt on there. If there are any EcoCar students on the stream, shout out to us. Give us a shout out. Anyway, so Sam, today what we're going to do is we're going to talk about code generation. We're going to talk about taking code that you've written in MATLAB or Simulink models and porting that over either into existing C++ or C or C++ code bases, or taking it onto hardware or ROS or things like that. So this seems like we get this comment all the time that, okay, MATLAB's a great prototyping environment, and then we hear of customers that say, okay, I've prototyped my algorithms in MATLAB or Simulink, and then I go and start rewriting that in C. Do you have any thoughts on that?
Yeah. So it comes up a lot because that's one of the big things, is that converting from one language to another kind of just introduces chances for issues to come up where there might be a feature in one language that's not in another, or you might, honestly, if you're like me, you just make a typo because you can't type. But with MATLAB and Simulink, one of the big things you can do is generate code, C or C++ code, directly from our functions that we write in MATLAB, or the big one is from Simulink models. So we can design all of our control logic in Simulink, and then without having to rewrite anything that we've just done. We might simulate against a simulated plant of the physical system we're trying to control, but we can then just take our controller and directly generate code and deploy that code in C to our embedded controller, or for, and we'll talk about this later, but there's quite a few kind of low-cost hardwares that we can just directly deploy to from Simulink without having to do any packaging ourselves.
Yeah. So I mean, at the end of the day, MATLAB and Simulink are both, what we like to call high-level interpreted languages, right? Where it sort of makes it easier because you're effectively writing code in the English language, but that's already, when you actually want to implement it, you want to put it onto a robot, you want to put it onto a vehicle, you want to put it onto something that flies, you're probably not running MATLAB on that device, just because you have very limited compute space and you've got a lot of things to do, right? And battery life as well. So what we're going to show you today is how to convert MATLAB code into C, Simulink models into C and C++, and also to program hardware. So without wasting too much time, let's jump right into an example. So first, what we've got here is, and it'll probably pop onto you guys' screen real quick, but essentially what we're going to start with is we're going to start with creating, generating C++ code from a simple MATLAB file. Again, this is just an example for demonstration purposes. You can surely take this and do similar stuff with your algorithms that you've already written. But essentially, there are sort of two workflows with code generation, or two cases as to why you'd use them. The first case that we spoke about is taking it into a different environment, integrating it with another code base, programming hardware. But then there could also be times when you're writing MATLAB code and you just feel like the performance is not good enough for you, right? So in that case, again, as we said, MATLAB's a high-level interpreted language. You may want to use some sort of executable or some sort of compiled version of your MATLAB code, and we're going to talk about this thing called MEX files then. But MEX is essentially one step in the code generation process. So if you guys can see my screen right now, I've got a very simple script written here. Let me just go ahead and load a quick picture in to show you. So we've got this nice Peppers image over here. If you've done anything with computer vision in MATLAB, this is the one image that you see all the time, right, Sam? And we make a lot of fun about this image. It's definitely one of the most popular ones in the documentation. Anyway, so let's just assume that I have the thing that I'm tasked with is I need to take this image, resize it to half its size, and then convert it into grayscale, right? So, and this is really where the power of MATLAB comes in, because these are essentially two functions in MATLAB. And if I go ahead and run this section real quick, you see that what I now have is a grayscale image of that same photo, but at half the size of it. Now, if I want to generate code from this, say I want to put this onto, I want to integrate this with another code base. I have to start by generating code for this. So the first thing that you have to do whenever you generate code is to take whatever algorithmic component you have in your code and convert that into a function, right? So because whenever you generate code in MATLAB, you're generating code from functions, not from scripts. So that's the sort of one high level thing that you need to think about when you're when you want to generate code from a MATLAB file. So the algorithmic portion of my little script here is essentially just these two lines of code. So let me go ahead and comment this out. And then I've at the same time, I've also written a small function that just wraps these two lines of code in, and this is what we'll be generating code from. So the first thing that you do once you sort of put your code into a function is we've got this thing called the code gen directive, and it's just it's a % symbol, a pound symbol, and then code gen. And what this directive does is when the MATLAB interpreter sees that code gen directive, it's going to check that function to see if it's code gen compatible or not. Now, what we mean by code gen compatible is there is so not every function in MATLAB is code generable. Like things like the plotting functions are not. There are some, and there's a whole list. I think they can pop a list, pop a link to that in the chat. Let me put it up. But essentially, if you go into the documentation and you look at all the functions and filter them out by C++ code generation, you can find a list of all the functions that you can generate code for. Okay, so what this code gen directive is doing is it's going to check and see if you're making any calls to these functions that are not code generable, and also some other sort of checks and balances that it'll do. And the way that you know that your function is ready for code gen is if you notice this little green box on the right hand side where my cursor is. If that's green, that means you're good to go. You can start generating code from it. Okay, so let me go back into that script that I have, and now that I've commented these two lines of code out, I'm just going to make a call to that function in here. So let's do I equals resize in gray of RGB, and if I go ahead and run this section now, you'll see that it actually does the same thing, which is great. Okay, so now that we've got our code in the function, let's go ahead and open up the MATLAB Code App. So again, at the MathWorks, we love apps, right, Sam? You've written a bunch of apps.
I've written quite a few.
we love apps at the MathWorks. So we have a MATLAB Code App which can help you generate code, and it'll sort of walk you through the steps that you need to go through. So the minute you pull it up, the first thing that's going to ask you for is it's going to ask you to it's going to ask you for the function that you want to generate code for. So in our case, that is resize in gray, the one that we just put together. I wonder why it's not. Typically, you could just tab complete it. Let me just check if you're in the right folder. Or you could just click on this and find it. There we go. That works too. Okay, so it's pulled in our entry point function, or the function that we're generating code from. It's going to create a project. Let's click the next button. It'll just sort of walk you through the different steps. The one thing that you want to do whenever you're writing this, whenever you're using generating code, is you want to have a harness script, some script that's calling the function like it would, when you're actually implementing it. So in our case, it's just that script that I was working with earlier, which is resize. Maybe let's just go and find it because I can't type.
Yeah, none of us can type here.
Yeah, so we call that script, and then what you can do is you can ask it to auto-define input types, and essentially when you click on that button, it's going to run that script, identify where it's calling that function, and then also identify what are the different inputs and outputs to that particular function, right? So we can see that it's identified that it's got one output, and the inputs are of uint 8, and then the size is whatever whatever we decide it to be. Now again, for this particular case, in our sort of harness script, we're giving it a particular sized image, right? But you can just as well go and say, have it unbounded or have it up to a certain size. You can sort of play around with these parameters as well. You can also add things like global variables and stuff like that here.
Yeah, and this is why I think it's really important that when you're, especially if you're taking like existing code that you didn't originally plan to generate code from, setting up a harness script and making sure you've got that working and running, and then just letting the app auto-define based on the way that you call it. I think that is really useful, especially if you're working with a code base that already exists. And between that and the code gen directive, these are here to really try and make this process as easy as possible, so that there's less manual work for you to do and tell MATLAB coder when it goes to generate the C code.
Yep. All right. So let's go ahead and hit next again. The next step in the process is to check for runtime issues. And essentially what's going to happen here is, remember that thing we spoke about, the MEX, MATLAB executables? It'll take your harness script. I find the function that it has to generate code for, generate a MEX function of that function and run it. And what this is doing is it's checking that there are no runtime issues, but it'll also check if it's doing exactly what it's doing before and after, right? Because you want to make sure that once you generate code, the performance is the same as what it was before you generate the code. So let's go ahead and click this check for issues button. You see that it'll tell you that it's going to generate the trial code first. This takes a couple of seconds. It's going to build a MEX file for it, and then it'll run that same harness with the MEX file in place of the original function. And if you saw real quick for a second, it popped up. It popped up the output, which is this is what we expected. So it's telling us that we've got no, there are no real issues. We can also go and view the execution count. So like you can see, if you sort of hover over that little green line, you can see how many times this function is getting called. Now, if you had this in a loop, obviously it would get called multiple, more times. But it looks like it looks like our code's built properly. There's no issue. There's no runtime issue, at least. So let's click on the next button and see what happens. And now we're in our final state where you actually generate the code, right? So there are some options. What is the build type? So when you say build type, you mean what are you trying to use it for downstream, right? So do you want to use it as source code? Do you want to use it as a MEX file? Again, remember, MEX can help you speed up your MATLAB code if you ever feel like you're not getting the performance that you want from it, because it's compiled MATLAB code rather than interpreted MATLAB code. We also have the option to export it as a static library or a dynamic library that you can add into some other external project, or just an executable that you can run on Windows or whatever operating system you're working on. So these are the few options. We're just going to choose source code for now because we can. And then also you can also pick the language, so C or C++. Let's just leave it as C for now. If you have a hardware board that you're trying to target, sometimes you have to use specific libraries and stuff for that. So you can either choose one of the many types from here. Also get other hardware support packages. I mean, we talk about hardware support packages in a little bit, but let's just call it MATLAB host for now because we're just trying to generate code and do nothing else. It'll automatically file in the toolchain. Let's look at some more settings. So these settings they can help you sort of fine tune how your code comes out, right? We've got a whole tutorial series that we can point you to later that goes through all of these different settings, but you can adjust things like speed, like memory allocation, code appearance, etc. So we're just going to leave it all as default for now. And let's hit generate, and we'll watch it generate code for us. So as you can see, it's sort of telling us what's happening. It'll go through the target build log. And then hopefully we can get a report at the end of it, a code generation report. So you see the code generation was successful. Let's open up the report and see what we've got here. So this is actually a real cool feature of this code gen functionality. I think they added it a couple of releases ago, but we've got this trace code option now. So what you see here is this is our original function. This is that resize and gray MATLAB, .m file that we had up here. If I click the trace code button, all that you're seeing down here are all the files that get generated from it. So you've got the way to navigate through these files is every time you generate code, you'll get a file name .c, which is the actual code that contains your algorithm. Then you also have a file name _initialize.c and a file name _terminate.c. And that's typically how the code gets generated. What you'll also see on the bottom is an example main. So if we click on this example main real quick, it's essentially just giving you a way, or it's showing you how they expect you, or how these files should be called. When you want to execute it. The file as is right now doesn't actually do anything, and there's actually a comment in there. So let me see if I can open this up. There's typically a comment in. Yeah, so it's telling you, invoke the entry point function in here, and then it'll sort of call that main file here, and then you see it's got the terminate, the terminate function in here as well. So you have to if you want to generate an executable, you can go in and edit this file, to call it in the particular way that you want to call it, and then compile it, or you could have just chosen the executable option and MATLAB would have compiled it for you. But this is used. Yeah, go ahead, Sam.
I was just going to say, this is kind of where, because we chose to just generate the source code. If you were including this code in a code base that you might have other hand code, or you're going to target something else on your computer and need to include some of that yourself, the example main is really just there to set up and show you how to use the auto-generated functions. It's not really intended to be the actual main function in your executable, because when we do the source code option, where the goal is really all the source files we generate, and the main is just there to kind of inform us on how we can do something.
Yep. Thanks for that comment, Sam. Okay, so let's just go back to our MATLAB file and we look at this trace code option. So if I want to know what does IM resize translate to in C code, I can just click this button, and let me resize this a little bit. But you can see that this one function basically translated to so many lines of code, right? Which sort of really shows you the power of MATLAB, right? Because you can sort of write code in a high-level language in a few lines, and then as we saw, just a few little clicks, and we're able to get that in C or C++ and take it into whatever other environment we have to take it into, right? So so this was at a very high level. This was how we generated the code, from a MATLAB file. Let me just go back to the app real quick, and I can show you something else. So now imagine that you've sort of gone through these steps, but you also have 100 files like this. What you can do is you can convert all that we did in this app into a script. So if you click on the ellipsis up here and you click convert to script, it'll basically just create a script in your current folder, and it's usually file name _script. And if you see what is happening here is essentially all those options that we clicked in the app, it's just converted that into code. So if you ever want to run this again, you can just sort of run this script rather than having to go through all those steps in the app. And something that you need to notice on the bottom is all that code gen command that's being called. And that's essentially how that's the command that we use to generate code. All right. Okay. Cool. So I think we've seen a little bit about a little bit about code gen for MATLAB. I think what we're going to do next is Sam is going to show us how to program a Raspberry Pi with something called a hardware support package. So while our awesome video crew in the back sort of moves our screens around, let's actually stop and take some questions while Sam's getting his screen set up.
Yep.
So let me just open up the chat real quick, and then we can see what's going on. Okay, we have a question about
I did see a question about DSpace and creating lib files for that. I think you'd probably have to ask the DSpace support team. I know that their code gen process generally leverages a lot of the same stuff in the background. So if you're going from a Simulink model to deploying that onto DSpace hardware, it's using the code gen system in the background, but they kind of have a lot of customizations in place, especially for doing it with Fortran. You'd probably have to ask them, because I'm not sure what they support for their particular hardware setups.
Yeah.
Right.
I see another question about generating a make file, because you want to use C in Linux by GCC. So if you're on a Linux platform, like if you're using Linux as your primary computer, the same process you can follow it there as well. You can essentially use MATLAB Coder and generate a MATLAB host executable using GCC. So that's definitely possible. I can also point you. I'm just going to look up a quick documentation page to show you about makefiles. So we can ping that to you in the chat real quick.
Sure. All right. So let's take a look. The first thing that I'm going to show you guys is just how you can get the hardware support packages, because we're going to need one of those to work with the Raspberry Pi I've got here. So I've got I think this is a Pi 3 Plus. I've had it sitting around. I really just kind of throw different stuff on it for demos and different stuff I want to try. Got a couple different SD cards, but I've got this one already set up to use with MATLAB. And the way that you go about that setup process is, if you can see my MATLAB desktop right now, on the tool strip on the home page, if you go to this add-ons part, there's a lot of different add-ons you can grab from like the MATLAB file exchange and example files that different teams at the MathWorks have posted. But when we're just looking for some of these hardware support packages, if we click the drop-down arrow, there's a section there to just open up just the hardware support packages that we want. And so when I open this,
Sam, quick question on the hardware support packages. First of all, are they free? And
yes.
Secondly, what sort of products do you need like under the hood to use these hardware support packages?
Yeah, so most of the hardware support packages, if they require a specific product, they'll list it. But the support packages themselves are all free. They're just optional add-ons that include some additional tooling to do stuff in the background. So for any of the like MATLAB support packages, they only require base MATLAB. For all of the Simulink support packages, they only require MATLAB and Simulink in order to do it. So with the stuff that we'll be doing here, we will be generating code, but with the support package for Raspberry Pi, you don't actually need Simulink Coder or Embedded Coder to generate the code and deploy it onto the device. So you can see the reason why I kind of separate the Simulink and the MATLAB side of things is that there are two support packages. For example, we've got the Arduino one here. The MATLAB support package, if you were only using MATLAB and just writing MATLAB code that you want to deploy, that would be all you would need. For the Simulink side of things, to actually generate code from your Simulink model onto an Arduino board, you'll need to install the Simulink support package. And I think if you don't have the MATLAB one already installed, it installs it for you, because I almost always just install the Simulink one and get both. So if we scroll down, for example, we've got the MATLAB one for Raspberry Pi, and farther down here we've got the Simulink support package for Raspberry Pi. And just for example, Like this one is a support package for something in the communications toolbox. So if it's toolbox specific, the support package will kind of outline what you need and what toolboxes it's built for. But if I just open up the Simulink support package one here, I've already got it installed. So instead, it's going to ask me if I want to manage it. But it's got some information on what we've got here. This is basically the same thing that you would see on the MATLAB file exchange if you were online. And if I click manage, that window over here, it's going to bring up the add-on manager here. And this is where you actually go through the process for flashing your SD card for Raspberry Pi to be set up for MATLAB and Simulink. You click this little gear icon, that's the setup icon. It's going to open this other dialog box. And this kind of walks you through setting it up. And so basically what you'll need is for the Raspberry Pi, you'll need to select which model you're using. And in this case, I'm working with a B+, but I actually also own a original Model B from way back in the day that I've messed around with in MATLAB as well. So you select that, and then this one's actually going to stop me in a little bit because I don't have an SD card inserted. But essentially, there's two options that you've got. You can either set up with the MathWorks provided Raspbian image, which is just an image for the SD card. It's got everything you need. It's going to be a fresh install of the operating system. If you've got an existing installation, you can also just customize that to work with the MATLAB and Simulink support packages. In this case, I don't really use these SD cards that I've got for anything besides the MATLAB stuff, so I'm fine just wiping them. I've got a separate one that I use when I'm toying around with other Linux stuff. So when I do that, it's gonna then ask me which of these I want to install. And in this case, I've already got this one downloaded and installed, but the base Raspbian image and is here, and then there's also the there's another one that's customized for deep learning stuff. If you want to deploy that to your Pi. After this, it's going to ask me to insert my SD card and validate my downloads and stuff. So I'm not going to keep going through this because I don't want to have to try and reflash the SD card when it's already working. But all of the support packages, if they require setup like this, they'll kind of walk you through it.
Yeah, it's always risky working with hardware on a live stream, right? That's just
yeah. I don't want to upset it or try to reset anything.
Yeah, I like calling that situation Mr. Murphy's playground because he likes to come in and mess with us. But anyway, let's continue.
All right. So what I'm going to actually show you on the MATLAB side in terms of generating code and deploying it directly to our Raspberry Pi is I'm going to actually have a webcam hooked up to the Raspberry Pi. I'm going to capture image data from it, and I'm going to do some simple edge detection. And this example is from our documentation, but I'm kind of walking it through, showing it in action with some live video. I'm going to have some stuff on my desk here. Should hopefully show you like what's going on. So in terms of the actual algorithm that it's running, it's pretty simple. It's not using any of the like more complicated computer vision style ones. We're just doing it with some convolutions. And if we run this, I've got the Teams pop up here blocking me, but all right. So if I go ahead and run this, this is just running through the algorithm with our favorite picture, the peppers.png. It's showing you that the edges that it ends up detecting. And it's not super crisp, it's not perfect, but really what I'm just going for here is I want it to be something kind of light because I want to be able to run it as I'm capturing new image data on my webcam. I don't want it to be something that's going to be too heavy for the Pi to process. So we can do it with a static image really easily, but taking this same function and basically the first thing you can do with the MATLAB support package is we can actually connect to the Raspberry Pi, and before we do any code gen or deployment of code, we can actually test out our algorithm by just using the Pi essentially as an I/O hub, and just having it send whatever data it's getting back to us. So here, go to this other script. What we're going to do is create an object for a Raspberry Pi, and then I'm going to create a webcam object on the Pi that's actually going to access this this other webcam I've got. And then I'm going to run through the same functionality here, but I'm going to get the image data from the Pi instead of from a static image. Go ahead and hit run and get my little pop-up here. All right. So this, just to kind of prove it, here's my hand. But I've got some more interesting stuff on my desk. I've got this this little model kit, and we can see doing live edge detection on a Raspberry Pi. We can see the mess of cables I've got going on to make all this work. Yeah, it's what you need to do hardware demos. But yeah, it's kind of the starting point for any code we want to deploy onto the Pi is rather than having to generate code every time, it's a good idea to try and kind of start encapsulating your functionality in functions or in just small sets of code that you want to test individually. So here, none of the actual code's executing on my Pi. It's just kind of serving as the interface for my webcam. But what we're going to do next is actually deploy this to the Raspberry Pi, and instead of doing it through MATLAB like this, I'll actually open up, I'll VNC over to the Pi, and we can see what's going on its desktop. So I make one more small modification here to my script before I deploy it. And what that is I've got the code gen directive, because now I'm going to want to generate code from this. And I've actually swapped out the imshow function for display image, because that's what we actually need to display the image on our Pi itself. Imshow is kind of the host PC showing it on there. But what we want is the Raspberry Pi to basically be doing all the work and not having to send any data back to our host PC.
Also, imshow is one of those functions that are not supported for CodeGen. So,
Yep.
Yeah, I think one caveat that I want to make while Sam's going through that is the Raspberry Pi support package is interesting because you could either use the Raspberry Pi as an I/O hub where you have like sensors and stuff that are connected to it, or you could also generate code from a MATLAB function and deploy it onto the Pi, which is what Sam's going to show you. But if you're on the Arduino, which is which is a different the other sort of low cost hardware board that we support, from MATLAB to the Arduino, you can only use it as an I/O. So you cannot like deploy an executable onto the Arduino from the MATLAB support package for the Arduino. But
yeah,
if you're on the Simulink side, you can deploy it and it'll run independent of MATLAB.
Yeah, and that just comes down to the Arduino itself. It's a bit less of a like micro processor and more of a microcontroller, so it just doesn't have the resources on board to do the live I/O.
Yeah.
Okay, so I've got my my little VNC viewer window open here, so we can see this happening live. So what I'm going to do is I'm actually going to go back up here, and I'm going to create a board object, and this is what I've got to do to create this this code gen and deployed application onto my Pi. So I'm going to go ahead and expand this so you guys can actually see it. I've got to create my my board object here, which is going to be a target hardware. It's got some information on my Pi. I have it all fresh, and I'm probably going to delete this afterwards, but this is just like the local IP address to the Ethernet port that I've got it connected to. And so after I do that, the next thing that I want to do is I want to actually come up here to deploy. I'm going to basically just call the deploy function. I'm going to tell it what board I'm trying to deploy to. In this case, my Raspberry Pi. and then I'm going to tell it what function I want to actually deploy and have and generate an executable for on the Pi. So I'm going to go ahead and click enter there. It's going to take a little bit of a second because it's got to do the code gen. And then it'll actually transfer those files to the Pi to create the executable for me. And then once that's done, I can go ahead and hop over to VNC viewer, show it happening. All right.
There we go.
Yeah, so similar to before, what it's going to throw up here is that code generation report. Hopefully this is still going. If I hop on over to the VNC viewer, I can see that on the Pi itself, I'm now doing everything. So I'm doing all of the I/O capture, the processing, and then because I used that display image function instead of the imshow on the Pi itself, I can actually get this this image. And if I had the Pi hooked up to like its own monitor or something, I would be able to just completely disconnect this now and just run it on its own and not have MATLAB connected or anything. So the other thing is that because this is packaged up all of our code, if we go over to if we go onto our Pi and go into this MATLAB workspace folder, go into 21A, we actually have the ELF file. So now I can, doesn't like my my power supply here. So you can see my function, my executable has stopped running because I only had it set up to take about 1,000 images before it shuts down. And now if I wanted to run it again, I can take this edge detection, that ELF, and execute it. And now, without doing anything on the MATLAB side, I've got my code running and doing the exact same thing again. So now, if I wanted to bring my Pi somewhere else and leave my laptop behind, it weighs a couple ounces, I could do and run to.
This is cool. No, hey, this is Sam.
But what I do is I just make use of some of the other hardware I've got on this Raspberry Pi board. I've got like an accelerometer and a little LED display. But I think for the general like Simulink workflow, it would be better to just show that on the Jetson side, and we can probably show the Raspberry Pi version of it with my very boring. Well, I won't say boring, but it's nothing fancy. It's just kind of rotating an image using the Excel. Oh, let's see. Okay, can everybody hear us on the other end? I think we lost audio for a second.
Yep. Am I still audible? Woohoo!
Okay.
Alrighty.
Cool.
Okay, cool. I am.
Okay. Well, Connell's getting some of this figured out. So I did see a question. Somebody asked if there's a recommended way of leveraging block diagrams in Simulink models in the more intuitive way of code changes tracking with Git. So you can do Git integration with MATLAB and Simulink and track changes to Simulink models using Git. The primary way to do that is using Simulink projects, or I think they're called MATLAB projects now because they're more than just Simulink. But that has a lot of integration with the Git workflow, and you could then also like generate code from your Simulink model and keep that in your version control system as well. The only thing to be wary of is that if you don't kind of separate it out and maybe put it in a separate like repository or something, if you just leave it in the default location, every time you code gen from Simulink, it's going to overwrite anything that is in like your generated code, and that might break some of the Git history of those files. So generally with when it comes to like model-based design and starting from a Simulink model and generating code from it, you really want to track your with your version control the changes to your design artifact, which would be your Simulink model and not the code itself, because the code is getting generated from the model. So the important part is to track changes on the model itself.
Yeah, I think that definitely goes back to the model-based design thing, right? Where you don't want to be touching. Well, I know that we saw that the code that's generated is, it's readable, it's editable, you can sort of play around with it. But I think if you're working at a large company like some of our customers, whenever they are generating code, they try and not touch the generated code. You want to touch things in the model. You want to make edits at the high level, and then just regenerate the code whenever you can, rather than it's just easier that way. I think it because one of the guarantees that we give you is that whatever code you've written in Simulink, when you generate code from it, it'll perform in the same way. So if you go ahead and edit the generated code, it's not very efficient, because you're gonna have to pass through 1,000 lines of code versus 5, like we saw earlier. But it also may change the performance of the algorithm. So while you can, and there could be times when you have experienced programmers that can go in and mess around with the generated code. I like to stay on the higher level language side of things, just because it's easier that way. I saw one more question in the chat that I think we should address before we move on. Sri Harsha was asking if you can take the C code to the TI Code Composer Studio and dump into the microcontroller. Yes. So effectively with TI, there are two ways of going about it. One is if you find the hardware support package for that particular board that you're programming, you can do that directly from MATLAB or Simulink, like we saw. But part of what generating it as source code or generating it as a DLL or a static library is you can take it into some other environment like Visual Studio or the TI Code Composer, etc., and dump it onto the hardware. So yes, that's definitely possible. All right, so let's hop onto the Jetson side of things real quick, and we can sort of show you how to go about this thing from Simulink. Hopefully my screen's up and visible to everyone. But the first thing that you want to do whenever you're trying to program the Jetson is you want to, kind of like how Sam did with the hardware object, you want to create that Jetson object in MATLAB. So the way we'll go about it is you just essentially call this Jetson function. You got to give it the IP address or the host name. I've assigned a static IP address to my Jetson, so I'm just going to keep it at that. And then also the username and password. And then you hit enter, and you see what it's going to do is it's going to check for a bunch of libraries. So it checks and sees if it's got the CUDA availability, if it's got NVCC, which is the compiler for the NVIDIA targets. You can see that it's also found the CUDNN or the TensorRT. These are two deep learning specific libraries that use the GPU on the Jetson. as well as some of the other stuff. But then it's also sort of giving you the details. It's telling you that what I have is a Jetson TX1. These are my different versions on it. And then it's also saying that it's got this Microsoft LiveCam camera connected to it. All right. So these are all my properties. Let's hop over to our Simulink model to take a look at this. Now, this model is actually from the documentation. I know it says Jetson TX2, but effectively all Jetson boards are the same. So this is Jetson TX1, TX2, or the Nano, they all have the same architecture, just different performance. Okay, so essentially what this demo is doing is it's using the camera connected to that Jetson board. It's piping in the images, resizing it, and let me try and zoom into this so it's a little more clearer. But so these blocks, right? This NVIDIA block that you see over here, and on this side as well. These are blocks that come with the hardware support packages, and they're called device drivers, right? So it's essentially sort of piping that information from whatever port your device is connected to into the processor, and then sort of into your code after that, right? So the way the NVIDIA board is set up is it's the camera comes in as 3 channels, so you have to sort of fuse them together to make it into an image. We resize them, and then we are passing it through this. And this is actually a new feature that they added as part of the deep learning toolbox. But you can actually you have predict blocks now. So if you've got a trained network, in our case, we're just using ResNet 50, which is something that comes with the product. Or you can download it as a support package. But you can essentially put your deep learning model in here, and it'll classify stuff for you. And then after that, it's just doing a quick calculation on the FPS, and then just annotating the result before it's piping it back to the NVIDIA Jetson screen. So again, as Sam showed you all earlier, you can find the NVIDIA Jetson support package in the add-ons manager. You can just download that, and you should see the blocks in here. But so this is a typical Simulink model. It's got, it's sort of your algorithmic portion is this part of the algorithm of the model, and then you've got the device drivers on the outside. But how do you set up this model to actually generate code for a particular device, right? So again, I told you, MathWorks, we love apps. They've actually added apps into Simulink now, which is when did the Simulink apps come up? That was
in yeah, it was in 2019B is when we made the transition from the old drop-down menu to the tool strip.
Yeah, but anyway, so you want to go and find this setup to run on hardware board app, and if you click this guy, it'll sort of show you these little options. But you can choose the different hardware boards. Now I only have the support package for the Jetson installed, but you can either select another hardware board. We just exit out of that, or you can that's where you can get more hardware support packages. But we're programming the Jetson, so I want to use the Jetson. We can go into some hardware settings that we have available. As you can see, it's got that hardware board selected here is Jetson. The Jetson has an ARM computer on it, so it's ARM compatible. Let's go and look at some target hardware resources. So these are those board parameters that you saw me setting up earlier, that the IP address, the username and password, as well as some build options. So for example, you can choose the build action to be one of a few things. You can choose it to build or build and run, etc. One thing that you should keep in mind is this build directory. So this is once the code gets built and put onto the hardware, if you navigate to the hardware, you can find that directory, and you'll see all your code in there, which is, I think Sam showed that on the Raspberry Pi side as well. So these are some options that you can set up. Here you have a bunch of code generation options. So this, things that control the code, you can control things like optimization. Do you want the parameters to be tunable, etc.? Do you want to generate a report? So on and so forth. There's some information about the GPU code that's generated. I saw a question in the chat about using custom code with these generated files. So whether you're in MATLAB or in Simulink, you always have an option to add your own custom code in there. So essentially, if these options are, I don't know why they're grayed out right now. Maybe it's something I did, but you can essentially put in, if you've got a source file in your current folder, you can sort of link to that over here and say, okay, I want to use this as the source file, or this is the header file, and so on and so forth. All right, so let's hit OK here. That's as far as hardware settings are concerned. Now, to actually build the code, you just go to this deploy option up here, and then you can click the build, deploy, and start, or the build. I'm just going to click the build button because I'm not sure how well this thing's going to work over a live stream, because there's a lot of applications running at the same time. So, but as you can see, if you click on this view diagnostics down here, yeah, it'll sort of give you some options as to what's happening. So it's saying that it's constructing the code from the Simulink model. There's something going on. I don't know why I can't see the build here particularly. This is always fun. But this typically takes a few minutes. Because especially with the GPU code, it's gonna create the kernels and stuff like that. So it'll distribute the computing over the GPU, and that's really powerful, right? Because you don't have to write CUDA code. You don't have to write figure out what the kernels are. Like I don't know anything about that. I know how to use Simulink, and I know how to use hardware support packages, and I'm able to get full use of that GPU on the Jetson. So while this thing's, let me try and cancel this and maybe open up the model again, because I think something's broken. But let's actually look at the chat and see if you've got any more questions coming up from there.
Yeah, sure. Okay, yeah. So somebody asked about resource utilization for when we deploy onto the Pi. So there are some options. I think these might actually require Simulink Coder and Embedded Coder. They're not included in the support package itself. But with those toolboxes, you can do what's called SIL, so software in the loop, and PIL, processor in the loop profiling. And what that kind of lets you do is deploy the code onto the target processor and look at how it's actually behaving and running on that processor rather than just on your computer. So if you are looking to profile the code and kind of look at how much of the Pi are you actually utilizing, are you basically getting overruns where the Pi's processor just can't keep up, and it takes a little bit more time than an individual time step might be in your model. All of that you would do through like the SIL and PIL options in Simulink, and like everything else, the SIL and PIL interface is now an app in Simulink under the tool strip. So
yeah. So I'm not sure if you can still see my screen, but I restarted the model and it decided to work, so I don't question it.
That's what happens when you do it live.
I know, right? But as you can see, the model is building. It's sort of telling us what's going to happen. It's compiling all those different functions in there, and yeah, it just takes a few minutes. That's about it. It's a little longer with the Jetson because I think that's primarily because of the kernels and all of that stuff. But like, what do you say with the Raspberry Pi? It's typically like a minute or so, maybe a couple minutes at most.
Yeah. Usually with the Pi, it's under a minute for actually like generating the code and compiling it. And then if you've got a really janky Ethernet cable like I do, sometimes transferring the file to the Pi is actually what ends up taking the longest. So
yeah. Let's actually look at some more comments while this thing's building. Is it possible to add debug messages to the generated code, or somehow add messages if an event happens? So yeah, so that's possible. That is a very advanced code generation topic. They have something called a TLC file. So if you right as I said it, it popped up on the screen, which is kind of cool. But so TLC is target language compiler. And you can take a look at the documentation for this, but I do think that it's a little bit out of the scope of this particular live stream. But essentially, a TLC file is what architects the code that gets generated. So it's possible for you to create a custom TLC file that can inject either lines of code into your generated code or messages or things like that. So that's definitely possible. What you need to look for is well, so TLC is the language that they use for that, but you need to look for the system target file, which is if actually I'll show you what the system target file is. So if you look at this ert.tlc, this is the system target file. So like you can browse through this and you can see a whole list of them. So obviously every particular hardware support package will have its own TLC file, but you can also create your own. One caveat, and I cannot stress how important this is. If you want to edit the embedded code or any one of these, if you want to edit that file, please make sure you save a copy in a different spot and then edit it. Because if for some reason you edit the TLC file that's on the MATLAB path that embedded coder is using, you will not be able to use embedded coder unless you download the software. So it's happened to me in the past before, and I had to sort of install embedded coder, and it's not fun. You won't know why it's happening. I think that's so that's definitely a caveat. But yes, if you go and edit the system target file in that, or the .tlc file, you can sort of inject messages and different artifacts into the generated code. Okay. All right. So I think the code built. It kind of lost connection to the Jetson, which is fine. But let me actually show you what the generated code looks like. So once you go ahead and generate the code, you'll notice a model_ert_rtw folder that gets created in your current folder, which you can see here. So this is where all the files are. This is where all the generated code is. So if you go in here, you see the CUDA files that are created. There should also be a report in here, unless I didn't turn that option on. Looks like I didn't turn the option on. But anyway, so this, if I open, so this is no, this is not the one. Just trying to find the CUDA file. I can't find it for some reason. But I think in the interest of time, let's yeah, I recorded a video last night of this thing running because I knew something like this would happen.
You do enough of these, and you
I've
learn
done,
that you should.
I've done. Better safe than sorry, right? So once that code gets generated on there, this is what it'll look like. So notice that you have remote build directory, start live stream, and then if you click through all those different options, all the different folders in there, you should be able. At some point you'll get to the same folder structure that you have in your on your computer, and then you'll see the ELF, the .elf file in there. So ex underscore DL model .elf, and then if you fire that up from there, you'll now see that it's able. So for example, if I'm not sure if it's too visible, but that the little yellow option on the sides are telling you what it is. So or telling you the prediction. So it's actually, I was really surprised with this one. I had an old modem lying around. It's actually able to pretty accurately say that it's a modem, which I was kind of surprised. So it's saying like 60% possibility that it's a modem. I was just talking to Sam earlier. I think it's identifying those Ethernet ports, and that's how it knows that it's a modem. But it's taking a look at my iPhone, and it's actually telling me it's an iPod. But I guess close enough, right? They kind of look the same. Anyway, so this is what happens. Once you sort of click through that button, it will it'll go ahead and dump the code onto the Jetson, and you should be good. I can send something in the chat about, so if you want to follow a similar process like this, but with MATLAB instead, I'll have them drop something in the chat for you, a video on how to do that with MATLAB. Let me just 1 second. All right. So we had a questions about MATLAB working under. So the thing that you're seeing on the screen, this is the Jetson. There's no MATLAB running on the Jetson. This is what we've deployed onto the Jetson from my Windows MATLAB computer. But yes, MATLAB can run under can run on Linux as well. It's built to support I think Linux, Mac, and Windows. So
yeah, and there's a list on the I think it's on the software requirements or the hardware requirements page for MATLAB. There's a specific set of Linux distributions that we actually qualify MATLAB on. So we run the full test suite and verify that it works on a specific set of distributions. If the distribution you're running isn't on there, that doesn't mean it's not going to work. It just means that we can't guarantee it'll work because we haven't run all of the tests ourselves on that distribution. There's a lot of, I've seen a lot of discussion online on how to get it running on some of the ones we don't list on the support page. And it's usually just a matter of getting a couple of libraries that don't ship with that distribution.
Alrighty. So I think we've sort of spoken for about an hour. We answered a few questions. I think a good next step is to sort of show you how you can get started. So, obviously, we have a lot of videos online about code generation. I think if you go to mathworks.com or even to our YouTube channel, I think most of our videos are pretty. I think whatever you'll find on mathworks.com, you should find on YouTube as well. There are some exceptions, but if you want to learn about code generation specifically, ooh, it's a big face of me. I don't like that. Why is it like this? Anyway, so we actually produced a code generation tutorial series a while ago. So if you could go onto our website and look for the code generation tutorial series over there. This actually walks you through 5 or 6 different videos. So essentially what we did here, but with a lot more detail and a lot more focus on like customizations and how you can add specific things to it. But then we also do Simulink, and then we also talk about hardware support packages, using Simulink as an integration platform to sort of bring MATLAB code in, Simulink code in, and then deploy it all into hardware there. So I recommend you go and take a look at this. All the code that we've used in here is all on GitHub. So if you're watching the video, you want to try the stuff out, just download the code and please let us know whether you liked it and if you need more stuff from us. The other thing that I wanted to mention is for hardware support packages, the best place to go to find them is you just go to mathworks.com/hardware. And here you'll see, all the different hardware that we support. So if you want to look by vendor, you can see there are, tons of vendors that we support. Arduino, ARM, they're the big ones. But there's also BeagleBone, there's also Texas Instruments, NI, DSpace. I know we saw a couple of questions on DSpace over there. But this is essentially where you can get started. So look on this hardware support page to find particular hardware that you're looking for and see if we've got support for it. And if we don't, we actually have a way in which you can request support as well. So trying to find that link. It's kind of weird because my website's a little different over here, but just give me a second. There's a link on this page where you can reach out to our developers and say, okay, hey, I want support for this particular hardware, and then it'll help them prioritize what they're writing support for in the future. So this is all for us today. Let's wait for a couple more minutes around, just in case there are any more questions that are coming in and such. But other than that, thank you guys so much for joining us. I think it was a real fun session for us to do. Code generation is a lot of fun.
Didn't have anything break too bad except connection to the Jetson, but
yeah,
it's what happens.
I feel like that was it wasn't the worst thing in the world. But yeah. If you guys have any questions, please feel free to pop it in the chat. We'll hang around for a couple more minutes. But if not, thank you so much for joining. The live stream. Please smash that subscribe button so you know that when we're going to do more live streams in the future. I know we've got a whole plan as to what's going to happen over the next few months. So please smash that subscribe button. Also,
you just always wanted to say that, Connell.
Yes. Also, I hope our video guys give me extra credit for driving more traffic to the YouTube channel. For being a MATLAB YouTube shill. How does that sound? Anyway.
Right. So I saw a couple things I just wanted to comment on. Somebody did ask about deploying a Simulink file onto the Raspberry Pi. We didn't quite have enough time here to kind of walk through the same process, but there's a couple examples in the documentation for deploying models onto the Raspberry Pi, and that code generation tutorial series that Connell mentioned. The last top video topic on it is where we deploy some vision processing to the Pi and connect a webcam to it. And we also have an Arduino that's doing some servo control. So that kind of walks through both the Arduino side of the workflow and the Raspberry Pi side of the workflow. And then we did the showrunners did post the doc page for it, but in terms of comparing like an old commit of your Simulink model, if you're using Git with your Simulink model, you can do it either through the project menu or by right-clicking on the file itself in the file explorer. But there's an option to basically to do a diff on the Simulink model to a previous commit, and then it'll pull them up side by side and show you what's actually different between the two Simulink models. In terms of by default, it actually doesn't show like block position. So somebody goes into the model and like moves a block 2 pixels down. We'll actually ignore that because it's not a functional change. But if you care about that stuff, you can actually turn it back on. So there's a lot of tools for doing the actual diff of 2 models and looking at what's different between them.
was a question about if this session is going to be available on its YouTube recording. Yes.
Yeah.
It will be available. Just trying to see that we haven't missed any questions. Doesn't look like so. And it looks like the questions have kind of died down. So, all right, guys. Well, thank you so much for taking the time out to join us. And we hope to see you again.
Yeah, thanks for hanging out. All right.